Good morning, students. Let's start our class. So today we are going to discuss few topics in binomial theorem, and that will logically conclude that topic later again after a few months. Once you are very well versed with solving, practice test problems, we'll again come back to this topic where we'll be discussing more advanced, concepts of binomial theorem, and that is true for the other, subjects and chapters as well. So today, what we are going to discuss is like the following. So first, we will discuss the binomial theorem for any real index, and then we will see some special cases, some particular cases. Then we will discuss about multinomial theorem, and after that we will discuss about the divisibility using binomial theorem. Several problems started coming on divisibility using binomial theorem. So there also I will explain you that how you can achieve those divisibility problem efficiently using some proper methods. Before I start the class, so could you please, confirm that you able to hear my voice very clearly and
Yes.
able to view the screen also, the digital screen what I shared?
Yes.
Okay.
Yes.
All right. Great. So, just a minute. I think a student has joined now. I need to accept that student. Yeah. Okay. So binomial theorem for any real index. Look into it here. Whatever we have discussed so far, that a plus b power n, where n was what? Natural number, if you recall, isn't it?
Yes.
That's why we are able to do NC1, NC2, NC3, and so on up to NCN. Without natural number, you cannot find the value of NC1, NC2, no? So now what happened here in this case is that if you look into it, let n be any arbitrary real number. N be any arbitrary real number and mod of x less than 1. You know, dear students, whenever you know that mod x is less than 1, that means x is in between -1 and +1. Whenever I say that mod x, we discussed earlier, if you recall, mod x less than 1, that means -1 less than x less than 1. And in general, mod x less than a implies minus a less than x less than a. Because you may actually take some time to get comfortable with modulus. That's why I said, but you are comfortable with inequalities because we have inequalities you have done in your previous years, right? Means you know what is meant by those inequalities. That's what I wanted to make. So then what? Let's come back to our topic. Let n be any arbitrary real number and mod x is less than 1. Then we can expand 1 plus x power n, something like this. Then we can expand 1 plus x power n, something like this. What is that? 1 plus x power n is equal to 1 plus nx plus 1 by factorial 2 into n into n minus 1 into x square plus 1 by factorial 3 into n minus 1 into n minus 2 into x cube, and so on. And it is an infinite series. That means you will find its r plus 1th term as n into n minus 1, as you see it here. N into n minus 1 into n minus 2 dot 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 up to n minus r plus 1 by factorial r, sorry, not mod r, factorial r into x power r. Now this is an important series. This is an important series not only from mathematics perspective, but from physics perspective as well. I will explain you why so. But before that, let's first comfortable with this infinite series. I repeat, if n is any arbitrary real number and mod x is less than 1, then the expansion of 1 plus x power n is like this, whatever you see. And the r plus 1 is term as denoted by tr plus 1 is actually like this, tr plus 1, that is the r plus 1 is term. Now here is one important point, what I said, that why it is important from physics perspective as well. Dear students, you will find in several physics, numericals and theoretical discussions, you will get that you need to expand 1 plus x power n where n is a real number and x is less than 1. Okay? Means, or more specifically I can say is that it is between -1 to +1. Then, due to approximations, we do not consider sometime from this term onwards, 1 by factorial 2 terms onwards. What I'm saying is that what you get 1 plus x power n, 1 plus x power n, what you are going to get? You are going to get is something like this, 1 plus n into x. Remember, x is a fraction. Then the next term will be what? Next term, as we see, n into n minus 1 by factorial 2 into x square. Na? Think about, as x is a fraction, x square will be very less number. Fraction means less than 1. So x square will be even lesser than 1. Next term will be x cube will be even lesser than 1, means very small number. So generally what happened, dear students, we only consider up to this. If I use a different color, on approximations, we use that 1 plus x power n is equal to 1 plus nx. And we ignore the rest of the terms. Lot of times I have experienced from my experience that students didn't understand that, okay, why you write 1 plus x power n equal to 1 plus nx, and sometime you can maximum extend up to this. In depending on the situation, okay, maybe x is very near to 1, not exactly 1, less than 1, but very near to 1. In that case, you can consider till third term, that means till x square. And after that, you ignore. You got my point, dear students, what I'm talking about? So this is very important from a physics numericals point of view. This is I wanted to discuss about the binomial theorem for any real index. Okay. Now, there are some special cases. So let me discuss about those special cases here, dear students. So when mod x is less than 1, so what we can say is that 1 plus x power minus n, it actually come from that above formula, is 1 minus nc1 into x plus n plus 1 into c2 into x square minus n plus 2 into c3 into x cube and so on. And 1 minus x power minus n is equal to 1 plus nc1 into x, and then you see the n plus 1 into c2 into x square plus n plus 2 c3 into x cube. That is the formula for 1 minus x power minus n. And you need to remember this, dear students. So now what I'm going to discuss is that I'm going to discuss about the multinomial theorem. Okay. So far what we discussed about binomial theorem. Binomial means a plus b power n, a and b, two terms are there. That's why it was known as binomial. Here we are going to discuss not only a plus b, so I will extend this thing, a plus b plus c plus d dot 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 up to suppose p power n. So now that expansion, how we are going to make, that we are going to discuss now. And I'll just discuss the preliminary thing because at this moment we should not get into very details of it because it is not the right time. But definitely will come, as I said in the beginning of the class, is that after a few months where you need to solve many more advanced problem on advanced problem related to multinomial theorem. What is multinomial theorem? Multinomial theorem tells that, I hope all of you are able to view the screen, dear students. Yeah.
Yes.
So multinomial theorem tells that for all n belongs to capital N, that means where lowercase n is a natural number, and for all I is equal to 1, 2, up to k, and xi belongs to R. So for all n belongs to capital N, and xi belongs to R. For all I is equal to 1, 2, 3, up to k, the expansion of x1 plus x2 dot 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 up to xk power n is like the following. It is a summation of factorial n by factorial a1, factorial a2, factorial a3 up to factorial ak into x1 power a1, x2 power a2, x3 power a3 dot 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 up to xk power ak. What is k? K is actually the summation is taken over k. Means here, over all the positive integers I, let me clearly say, here the summation is taken over all positive integers ai, where I is varying from 1 to k. Got it done, dear students? Why? What is k? K is the last term, x1 to xk, such that we can have the following conditions to be true. Let me repeat once more. If you look into this summation, that x1 plus x2 plus dot 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 up to xk power n, that is equal to summation of n factorial divided by a1 factorial into a2 factorial into a3 factorial up to ak factorial into x1 power a1 into x2 power a2 into x3 power a3 dot 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 up to xk power ak. Here the summation is taken over all positive integers ai for all I equal to 1, 2 up to k, such that the following two conditions hold true. What are the conditions? That ai should be in between 0 to n, obviously, because we are taking factorial of these numbers. Okay. And I is from 1 to k, all natural numbers from 1 to k. And summation of all ai from I equal to 1 to k should be equal to n. That you can think of when you did that a plus b power n in any term, the power of a and power of b, if you add, that sum up to n, if you recall. Dear students, when you did a plus b power n, what is the r plus 1th term you got? NCR into a power n minus r into b power r, correct?
Yeah.
If you add these two powers of a and b, is actually n, na?
Yes.
But in context to our discussion of multinomial theorem, b and a are nothing but a1, a2, x1, x2, correct? No? You got my point, dear students? In context to our discussion, a is become x1 and b become x2. Then whatever their power is, a1, a2, a3 up to ak, that has to be sum up to be n. Okay. Now the thing is that how we can experiment this thing? You can just take small term a plus b plus c power 2. That means x1 plus x2 plus x3 power 2. You can just experiment this expansion. Okay, what I'm talking about, this expansion you can experiment with couple of examples. You can take x1 plus x2 plus x3 power 2 and go with this summation, and x1 plus x2 plus x3 power 3 and go with this summation. Then you will understand why this formula is. Just for checking that informing this formula may not have your idea very clear. Okay. And another point in context to this discussion is that how many terms are there in the expansion of x1 plus x2 plus xk power n? Answer is there are n plus k minus 1 ck minus 1 terms. So there are n plus k minus 1 ck minus 1 terms in the expansion of x1 plus x2 dot 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 up to xk power n. So as I said before, discussing multinomial theorem, that we will not deep dive into it right now because priority doesn't tell us to do this thing right now. We will, focus on which are the relevant topics, but we will come to multinomial theorem in big manner after few months once we are very well versed with solving all the practice test problem as available in the online test platform at www.KonarClasses.com. Now, what we are going to discuss now? We are going to discuss a very important and a practical topic of divisibility. If you recall, dear students, we have solved a couple of problems, okay, on divisibility. Okay, and purposefully I didn't mention that what is the theory behind it. Why, because once you start solving couple of problems, we did 2 problems actually earlier. And those who are not able to recall, you can go back to my previous video lectures, which are available on YouTube as well. Okay. And you can look into all the video lectures I publish after the class. You will find it out that there we discussed couple of divisibility problems. One of the problem was from DPP, if you recall. But once you start solving problem, then you understand, okay, what is the pattern? Now I am going to discuss that pattern to you. And also we will solve couple of problems together. And then you will understand, this is the way to apply this, particular pattern to solve this problem. We will relook to the problem what you solved, and you'll find you'll get a completely different perspective. Not completely different perspective per se, but you will see in a very, in a good, in a very, very, in a step-by-step manner, what I can say. So let me first, explain you that, how you should approach the divisibility problem and what is the background behind it. Let me first, just give me a second. Just let us, relook. What is that 1 plus alpha power n? I hope all of you agree to me this formula. Correct? 1 plus alpha power n are very easy. NC0 into 1 power n into alpha power 0 plus, that is actually 1. Then NC1 into 1 power n minus 1 into alpha. 1 power n minus 1 is 1. That's why NC1 alpha. Then NC2 alpha square. Then r plus 1th term should be, NCr into a power r. And then n plus 1th term should be NCn into alpha power n, because there are n plus 1 terms. Correct or not? Very simple. Not a big deal. Now, just we take into the left hand side 1. Then what we get? 1 plus alpha power n minus 1 becomes what? NC1 into alpha plus NC2 into alpha square plus dot 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 plus NCr into alpha power r plus dot 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 NCn into alpha power n. This one, no, dear students. If you look into the terms in the right hand side very clearly, very minutely, you will find all are multiplied by alpha. Correct or not? NC1 into alpha plus NC2 into alpha square plus NCr into alpha power r dot 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 plus dot 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 up to NCn into alpha power n. All are multiplied by alpha, na? Hello, all of you agree? Dear Sagnik,
Yes.
Divanshu, Srijita, Mohar. Okay.
Yes. Yes.
So that
Yes,
means
sir.
what we get is that
Yes,
1
sir.
plus alpha power n minus 1 is actually divisible by alpha. That means alpha is a factor of the expression 1 plus alpha power n minus 1. Correct, na? Now, what you're doing, so this part is well understood. Let me use a different color. So this one is well understood. Now, what is the value of NC1? If you recall, the value of NC1 is actually n. You can formula factorial n by factorial 1 into factorial n minus 1, you will get n.
Yes.
Or without using formula, you can just use the actual meaning of NC1. What is the actual meaning of NC1? Out of n distinct objects, you are taking one. In how many ways you can select? Any ways you can select.
Yes.
I'm just recapping. Multiple ways you can look into this one.
Yes.
Then what happened, dear students, is that 1 plus alpha power n minus 1 minus n alpha means this thing we take it in the left hand side. Then what we are going to get? 1 plus alpha power n minus 1 into alpha, na? Minus n alpha, correct? And that is equal to what? That is equal to nc2 into alpha square plus dot 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 plus nc r into alpha power r plus dot 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 up to ncn into alpha power n. If you look into this, dear students, that right hand side expression is a factor of alpha square, means it is divisible by alpha. Right hand side is actually divisible by alpha square, very correctly to say. Because alpha square is multiplied with each of the terms. Now remember, there are some problem. Now prove that this expression is divisible by 64.
Yes. Yes.
Correct, na? 64 means what? 8 square. So there we need to think is that, oh, if this problem, then I need to make it in terms of 8 square. Remember one problem we have done earlier?
Yes.
So this gives you an idea. What is alpha then? Alpha is actually 8 because 8 square is equal to 64. So somehow we need to express that entire expression like that 1 plus 8 power n minus 1 minus n into 8. Got my point, na, dear students? Then let's do one thing. Let's take care of this one. Then what is the value of NC2, dear students? If you take NC2, it is actually n into n minus 1 by 2. And if you take into the left hand side, you will get this. And right hand side, what you will get, all are actually terms multiplied with, alpha cube. That means what? What we can say? That 1 plus alpha power n minus 1 minus n alpha minus n into n minus 1 by 2 into alpha square is actually divisible by alpha cube. And after that, you don't need to proceed. You don't need to compute and show that it is divisible by alpha power 4. It is not required. Let's become very practical. Either it will be, divisible by alpha or divisible by alpha square or divisible by alpha cube. Divanshu, is it absolutely clear?
Yes, sir.
Okay, great. Thank you. So then what we conclude? So from these above three equations, we conclude that three things. Okay, let me show it to you first. So from the above equation 1, 2, and 3, we conclude that the expression 1 plus alpha power n minus 1 is divisible by alpha. I hope all of you agree to me. If someone is not or someone is not able to understand, please do let me know. Second point is that 1 plus alpha power n minus 1 minus n alpha is divisible by alpha square. And third one is that 1 plus alpha power n minus 1 minus n alpha minus n into n minus 1 by 2 into alpha square is divisible by alpha cube. These three things you need to just, make that pattern reside in your mind. Then after having this, things completely, stuck to your, mind, then you start solving a problem on divisibility. You will find, oh, all I need to do is that finding the value of alpha from that expression and finding the value of n. Correct, my dear students? We can solve some problem together. Let's solve a problem together. Okay. So you can write along with me. If n is any positive integer, if n is any positive integer, comma, so that 2 to the power 3n plus 3 means power of 2 is 3n plus 3 minus 7n minus 8 is divisible by 49. Did you get my point, dear students? So what I'm saying is that let me also write it down here. If n is any positive integer, okay, so that 2 to the power 3n plus 3 minus 7n minus 8 is divisible by 49. What we are going to do, dear students, let me write it down here, and then we'll solve this problem together. We'll explore that how our, the learning what we did now is actually going to help us to, prove this thing very, easily. Correct, now, dear students? Okay, so now all of you can be in the part of this discussion, and all of you please involve, all of you please provide your comments. So one thing to clear, that we need to divide by 49. That means somehow,
7.
something like that, 7 is coming into the picture, right? Isn't it? That should be our target. Always that should be our target. That something to 7 to is there. Correct, no? So let us solve together. And you also open your notebook and start solving with me. And then you'll get the real hands-on experience that how to solve this kind of problem. What is the given expression? Our given expression is that 2 to the power 3n plus 3 minus 7n minus 8. How we can write this thing? We can write 2 to the power 3n into 2 to the power 3.
Yeah.
2 to the power 3n into 2 to the power 3. See, dear students, the moment 2 to the power 3, you get 8. 8 you can write in terms of 1 plus 7, not dear student. Minus 7n. 7n is already there. Minus 8. Minus 8 you can write in terms of 7 plus 1. We'll see all these things. Okay. Correct or not?
Yes.
Write this thing. Now let us focus mainly on 2 to the power 3n into 2 to the power 3 and all these things. 2 to the power 3n means what? 8 to the power n, dear students. All of you agree to me? 8 to the power n into 8, 2 to the power 3 means 8. Minus 7n minus 8. So now what we can write is that 8 to the power n is equal to 1 plus 7 power n. So what we can write, 8 into 8 to the power n is 1 plus 7 power n. Correct or not?
Yeah.
Minus 7n. Correct? Minus 8. That is equal to what? That is equal to, now we can start expanding.
Yeah.
Correct or not? How we
Yes.
can expand? If we start expanding, 1 plus NC1 into 7, correct or not?
Yeah.
NC1 into 7 plus NC2 into 7 square, correct or not? In that way, finally you will end up with NCN into sorry, NCN into, I'm
So,
sorry, NCN into 7 power n. Correct, no, dear students? So in first bracket it is self-sufficient. Unnecessary, we should not give second bracket. First bracket, okay? Minus 7n minus 8, correct? Minus 7n minus 8. We are almost there. You see, what we are getting out of it, 8 plus what you are going to get is that we need to prove it is that it is divisible by 49.
yeah.
Correct, na? 8 and 8 will get cancelled, na?
Yes.
Correct?
Yeah.
Then what you are going to get? You are going to get, one thing is that if you see here that once you get that NC1 in, that is equal to what? That is equal to n, 7n. 7n and 8 will get cancelled.
Yes.
Correct or not?
Yeah.
So what is the first term you are getting? 8 into 1 is 8 plus NC1 is n. Correct or not?
Yeah.
In 5 into 5 into, sorry, not 5 into, I'm sorry, 8 into 7. Correct, na? So 56 into n. Correct or not?
Yeah.
56 into n. And after that, all the terms are 7 square into something.
Yes.
I'm not writing all these things from here on, here till here. Correct, dear students? All terms are 7 square into something.
Yes.
If I use a different color, then you'll get clear, dear students. So what I'm saying is that from these terms onwards till here, all are 7 square into something. So that's why I wrote 7 square into something minus 7n minus 8. So 8 and 8 to got cancelled. 56 minus 7 is equal to what? 49. 49 is equal to what? 7 square.
Yes.
Correct or not?
Yes.
So then what you are going to get it here? So 7 square you can, then you will get it here n plus something, no?
Yeah.
N plus, we are not interested to write all these things because our target is to make it as a multiple of 7 square. 7 square is 49. Clear or not clear?
Yes.
So you see now, once you start solving problem, first and foremost thing, dear students, is that 49 should give you a clear idea that what you need to proceed. 49 should be either alpha or power of alpha. Correct or not, dear students? Dear Srijita, Divanshu, Sagnik, absolutely clear, na?
Yes, sir.
That should be the thought process. That here 49 is power of 7. Power of 7. So power of 7 means alpha has to be like this. That should be the clear-cut indication. Absolutely. And once you start getting it, you know that, yeah, I can now start solving problem very easily. Next problem, we are going to solve it. Clear, no? Any doubt here? Okay. Okay, you can write along with me the second problem also. Please start writing along with me that so that okay, before so that you can write if n is a positive integer, if n is a positive integer, comma, so that 3 to the power 4n plus 1, 3 to the power 4n plus 1 plus 16 into n minus 3 is divisible by 256, is divisible by 256. Let me put the question here in this a digital board so that you can have a look into it clearly. I hope the question is visible to you, dear students.
Yes.
Yeah. Now, I want you to spend some time on this question and you tell me how you are going. We will solve together like the previous one. But what comes to your mind to solve this one? What do you think? That how we are going to approach it? So what 256 brings to your mind?
16 square.
Correct. 16 is brings to your mind. 256 means 16. Something though we need to do with this thing. Correct or not? Clear or not clear?
Yes.
Okay. So how you should express it? So already 16n is already there, one term, middle term, right? Now, dear students. Correct? So how you are going to proceed it? So something like this. That let me write the entire expression here. 3 to the power 4n plus 1 plus 16 into n minus 3, correct? That we need to rearrange, means just rewrite, but keeping in mind that, okay, 16 is there, okay? So 3 to the power 4n plus 1 and there is minus 3. So we can take 3 common. Then what we are going to get? 3 to the power 4n minus 1.
Yeah.
Plus 16 into n, correct, na, dear students? Then what we are going to get is that we are going to write 3 into 3 to the power 4n means what? 3 to the power 4 power n.
Yeah.
3 to the power 4 power n minus 1 plus 16n. Now, we should be bothered about the factor of 256. Okay? Factor of 256 means, okay, let's write 3 power 4. What is 3 power 4?
81.
81. Very good. Okay? Now that gives you a very clear idea that what we should proceed. So 81 power n, it is 81 power n minus 1 plus 16n. Correct, no, dear students? Now, if you look into 81 power n, so you need to think back a little bit, that 81 you can express in terms of 1 plus 80. But are you going to achieve anything? Then you need to think of little bit. So let me use a different color and 81 power n. And that also you need to apply, in future problem. 81 power n means 80 plus 1 power n. Correct or not? So let me write 1 plus 80 power n, that is equal to 1 plus 80 power n. 1 plus 80 is the better way of writing, so that 80 power 80 indices will come. Then what we'll get? Here you will get 1 plus all terms related to 80.
Yeah.
Now 80 is a factor of what? 80 is a factor of 80 square. If you see 80 is equal to 80 square is a factor of 256. 80 square contains 256 as a factor. What I wanted to mean. Look at. Correct now, dear students? All of you agree to me?
Yes.
If you see 80 is equal to 5 into 16, correct or not? So 80 square contains 256. So now that is the justification that why we should express 81 power n as 1 plus 80 power n. Correct, no? So then what you will do, dear students? I will not proceed further. Rather, I should give you some more problems so that, but your task will be to give it to me before we start our class tomorrow. That is equal to what? That becomes 3 into 81 power n. I am going to write is that 1 plus 80 power n minus 1 plus 16n. Correct, not dear students? Now, what we want to do, we want to make sure that all the terms what have been given in the expression, that is actually multiple of 256. And if you do it, you will get it actually. I'm not proceeding further. Rather, we should utilize this time to give you few more problems. Is it clear that, especially here, that why 81 power n is actually 1 plus 80 power n? Because of that, 256 is actually coming to, from the background. Correct? So how we approach this problem? But think about that, if that before the class today, if this same problem has been given to you yesterday, then you may think that how I should proceed. But today you get confidence, right? Why? Because what has to be divisible by, that is our alpha in the theoretical discussion we will treat today. Correct or not? That is going to give you the confidence. Okay, now I can approach the problem. All are related to, see, our main purpose is to find the value of alpha and n. Let me go back to the theory again. Our purpose is whatever is given, can we choose alpha? Choosing alpha is not a big deal. If you see the first problem, here choosing alpha was that 7 because 49 was there. Then our entire thought process of expressing the term, that is 2 power 3n plus 3 minus 7 and minus 8, I am discussing about the first problem, should be confined. Our thought process should be confined with power of 7. Correct, na? Similarly, if you look into the next problem, what we get, instead of in that previous problem it was 49, and in this case the problem is 256. 256 means 16 square. So our thought process will tell, okay, confined your thought to so that you can express 3 power 4n plus 1 plus 16n minus 3 as a power of 16. And this is also a special case why 81 power n came. 81 is also again think about where can can I make some relations with the power of 16? Yes, we get 81 is equal to 1 plus 80, where 80 is a power of 80 is a factor, 80 is multiple of 16, correct? That means that gives you a confidence. Yeah, I can now proceed with this. These are the steps, and what you see, I did. You see the way I've expressed, like you only. I told you, open your notebook and do along with me. Correct, na? Okay. Now, what I'm going to do, dear students, is that I'm going to give you a couple of problems, and your task will be in the next, couple of hours after the class to work on these problems and get back to me. Is it fair enough? Okay. So, or if someone has some other activities, you can send me later also, but do not delay. But by evening, okay? Because maximum by evening, you please send it. Next problem, you can write along with me. I'll also show you in that one. Okay, so that the expression I'm going to read out, 3 power 2n plus 2, 2n plus 2 minus 8n minus 9 is divisible by 64. By 64 for all n belongs to capital N. Let me use a different way of expressing this thing. Just a minute. So, Divanshu, I want to know from you that what comes to your mind after looking into this problem. Let me first give the problem.
64 is 8 square.
A little louder, please.
64 is 8 square.
64 is 8 square. Something in my mind, it is coming. All of you agree? What he said? Yes. Something though it is in my mind is that whatever the expression has been given, that has to be, a power of 8 square. And 3 power 2n plus 2 gives you an enough indication. That means 3 power 2 power n plus 1, na? 3 power 2 means what? 9. 9 is nothing but 1 plus 8. See, without touching our pen and paper, we can understand that, yeah, we can prove it. Correct or not?
Yes.
And 9 is there right hand side, not right hand side, the last part of the expression 9, that is 8 plus 1.
Yes.
So without touching pen and paper, we can think that, yeah, we can approach this problem because 64 is 8 square.
Yes.
Correct, no?
Yeah.
Now, next problem I am going to give you, dear students. So next problem you can write along with me is that show that 11 power n plus 2 11 power n plus 2 plus 12 power 2n plus 1 is divisible by 133 or all n belongs to the set of natural numbers. Here you need to think of little bit of 133. How we can express 133? Okay, it is not directly coming as a square, but can you play with this number 11 and 12? Let me first give the question first, dear students. Little different type, but think about how you can do. 133. Okay. 11 is what? 11's power is what?
N plus 2.
Hmm?
N plus 2.
11 power is n plus 2. Okay. So, think about that how you can express that, 144, 121. You try it actually. Anyway, but we should complete before we start our class tomorrow. Okay. Why? Because tomorrow we are going to discuss a new topic called linear inequalities.
Okay.
And I'm going to give you a couple of more problems, uh, and that you will get it along with the class note, dear students. Okay, I'll give you a couple of more problems.
Okay.
So I appreciate that all of you, almost all of you, okay, submitted all the DPPs and you start getting your evaluated paper also available. As I said yesterday, that whenever you find that your marks is less than 1 for a particular question, please look into your solution and think that why it is less than 1 and then get back to me. If you find the mistake by your own, it's okay. Otherwise, you can get back to me. So this way, the preparation is going very rock solid manner. Rock solid, why I'm saying? Because, it is so concrete that if you have done all the DPPs, now you can start working on the practice test problem. Correct. And I have seen few of you also started appearing PTs, that is practice tests. So anyway, with this note, I would like to conclude the class for today. Tomorrow, we will start discussing linear inequalities and we'll learn a lot of interesting things there. Okay. All right. If you have any specific comments, please do let me know before we conclude the class for today. All right.